Hello dear learners. In this video, I am going to demonstrate the determination of strength of hydrochloric acid using conductometer. Demonstration of this experiment will be as follows. Aim and theory, apparatus required, solutions required and their preparations, demonstration of the experiment, graph and calculation, finally results and conclusion. Aim of the experiment is to determine the strength of hydrochloric acid conductometrically using standard sodium hydroxide NaOH. The principle behind the experiment is the conductance of the solution depends upon the number and the mobility of the ions. Mobility is nothing but movements of the ion. The addition of one solution into another will automatically alter the conductance of the solution. In the titration of sodium hydroxide with hydrochloric acid, the sodium hydroxide is a secondary standard and its concentration can be found out using volumetric method by titrating with a primary standard called oxalic acid using phenolphthalein indicator. In the titration of sodium hydroxide with HCl conductometrically, before the addition of sodium hydroxide, the conductance of the HCl solution is high due to the presence of H plus ion. As the NaOH is added gradually, the H plus ions are removed by OH minus ion, forming a weak ionized water molecule. Hence, the conductance of the solution falls continuously with the addition of NaOH till the end point reaches. After the end point, further addition of NaOH will increase the conductivity of the solution due to the presence of hydroxide ion. The end point is determined by plotting the graph between conductance of the solution in y-axis and volume of titrant in the x-axis. You will get a two straight line. The point of intersection gives the end point. Next we shall see what are the apparatus required for this experiment. Conductivity bridge, conductivity cell, 100 ml beaker, glass rod, burette and conical flask. Then we shall move on to the what are the solutions required for this experiment. We need 0.5 normal oxalic acid, 0.5 normal sodium hydroxide, phenolphthalein indicator, 0.1 normal potassium chloride solution, conductivity water and 1 normal HCl solution. Now we shall see the preparation of solutions required for this experiment. First, 0.5 normal oxalic acid for 100 ml. Weigh 3.5 gram, 15 gram of oxalic acid and dissolve it in a conductivity water and made up to 100 ml. Shake it well for uniform concentration. Next solution is 0.5 normal sodium hydroxide. 2 gram of sodium hydroxide is dissolved in a little amount of water. And transfer it into a 100 ml SMF. Then made up to 100 ml. Next, I am going to prepare 1 normal HCl solution. For this, I am taking 10 ml of concentrated HCl and transfer it into a 100 ml SMF and made up to the mark. This is 1 normal HCl solution. Next, we shall see the standardization of sodium hydroxide. Sodium hydroxide is your burette solution. So wash the burette with a distilled water. Then rinse the burette with the sodium hydroxide solution. Fill the burette without any air bubbles up to though it is a colorless solution, make the solution as a lower meniscus. Then your pipette solution is oxalic acid. Rinse the pipette with the oxalic acid. Pipette out 20 ml of oxalic acid. And pour into a clean conical flask. Add 2 drops of phenolphthalein indicator. Then titrate it against the sodium hydroxide solution which is taken in the burette. Appearance of permanent pale pink color is the end point. This is the end point, appearance of permanent pale pink color. Then the titration is repeated for concordant value. Before that, see the end point, that is 20.7. Again pipette out 20 ml of the oxalic acid. Add 2 drops of phenolphthalein indicator. Do the experiment to get the concordant value. Again it is 20.7. So 20.7 is the concordant value. Before starting the actual experiment, let us calibrate the instrument, for which about 40 ml of 0.1 normal KCl is taken in a 100 ml beaker and the conductivity cell is placed in it. And the conductivity cell is connected to the conductivity bridge. There is a knob which is used to adjust the cell constant to 12.8. And the conductivity bridge consists of 3 knobs. The first one is for setting the temperature and the second one is for mode, for which we can change the temperature, conductance and conductance at 25 degrees Celsius, and the last knob is range in terms of millisiemens. In order to calibrate the instrument, set the temperature at 25 degrees Celsius. So adjust the knob to temperature mode and fix the temperature at 25 degrees Celsius. Then keep the knob at conductance at 25 degrees Celsius and fix the reading to 12.8 by adjusting the knob. Adjust this knob. Using this knob, adjust the value to 12.8. Now it is 12.8. In the next step, measure the actual temperature of the solution. It is 26 degrees Celsius. Then, using the temperature knob, set the temperature of the solution. The temperature of the solution is 26 degrees Celsius. Now the instrument is calibrated and ready to perform the experiment. Before performing the experiment, wash the conductivity cell with a conductivity water. The given unknown solution is made up to the 100 ml mark using the conductivity water. The unknown solution is made up to the 100 ml mark using the conductivity water. Then shake the SMF for uniform concentration. From the unknown solution, pipette out 10 ml of the unknown solution and transfer it into a 100 ml beaker. Then add 40 ml of conductivity water. The conductivity cell and the glass rod is placed into the solution. We are going to measure the conductance. So adjust the knob to conductance. The conductance of the hydrochloric acid is 15.2. Then add 0.5 ml of NaOH into the beaker. After adding 0.5 ml of sodium hydroxide into the beaker, the conductance value decreases. Now it is 13.1. The conductance value decreases due to the formation of water molecule. Then again add 0.5 ml of NaOH into the beaker and measure the conductance. It is 11.5. Then the titration is carried out until the neutralization takes place. For 2.5 ml, the conductance value is 7.5. Again, I am adding 0.5 ml of NaOH and the conductance value is 6. I am adding 0.5 ml. For 3.5 ml, the conductance value is 4.7. For 4 ml, the conductance value is 4.6. For 4.5 ml, the conductance value is 5.7, which means there is an increase in the conductance value, which shows the neutralization takes place. After further adding 0.5 ml of NaOH, the conductance value will keep on increasing, which shows the presence of OH minus ion. For 5 ml, it is 6.4. For 5.5, the conductance value is 7.4. For 6 ml, the conductance value is 8.1. For 8.5 ml, 6.5 ml, the conductance value is 8.9. For 7 ml, the conductance value is 9.8. For 7.5 ml, the conductance value is 10.7. For 8 ml, the conductance value is 11.5. With this, we are stopping the conductance measurement. Now we can find the strength of hydrochloric acid by plotting the graph between volume of NaOH in x-axis and conductance in the y-axis. We will get two straight line, and the point of intersection will give the end point. For standardization of sodium hydroxide, I have taken 3.15 gram of oxalic acid. Using this weight, I am going to calculate the strength of oxalic acid using the formula weight of the substance into 10 divided by molecular weight. Weight is 3.15 into 10 divided by 63. Therefore, the strength of oxalic acid is 0.5 normality. The volume of NaOH consumed is 20.7 for this titration. Using the titration value, I am going to calculate the strength of sodium hydroxide, that is V1N1 is equal to V2N2. V1 is 20 ml, N1 is 0.5 normality and V2 is 20.7 ml. Therefore, the strength of sodium hydroxide is 0.4831 normality. These are the readings I have measured during the conductometric titration of sodium hydroxide versus HCl. This is the graph obtained by plotting volume of sodium hydroxide in x-axis and conductance in the y-axis. Two straight lines are obtained. The point of intersection gives the end point, that is 3.7 ml. Then I am going to calculate the strength of hydrochloric acid using the formula V1N1 is equal to V2N2. Volume of hydrochloric acid taken is 10 ml. Volume of NaOH, that is taken from the graphical value, 3.7 ml. Then the strength of NaOH is 0.4831. Therefore, the strength of hydrochloric acid N2 is equal to 0.1787 normality. The result of the experiment is the strength of hydrochloric acid present in the whole of the given solution is 0.1787 normal. Hope you have understood and learned the experiment. We shall see in another video. Thank you.